Actually, this is not newer material. This is our review for our test. Test is going to be on Thursday. It just works better to be on Thursday. So it'll be in class. You don't have to come in during advisory to do it. If you have a great score, which many do, and you're done, then you get a free day on Thursday. We'll cover some new material tomorrow, so you can use Thursday to do your homework. You can work on stuff from another class, whatever. So let's zip through this. Okay, what I did is I just did an analysis of the problems that people missed most frequently, and we're going to look at those. So what about this one? This is the one most commonly missed. You now are experts on these patterns. So what pattern would I use here? A cubed plus B cubed, exactly. A cubed plus B cubed. And everybody, what does that equal to?
A plus B.
Plus B.
A squared minus AB plus B squared.
There you go. There it is. Good. And so our job here, remember, our job is just to determine what's taking the place of A and what's taking the place of B, right? That's it. So we want to take this first term and write it as A cubed, and the second term and write it as B cubed. Well, what's our A? What's the thing that we're cubing in the first term?
27.
Okay, but what are we cubing to get 27x cubed? 3x. Okay, so 3x is our A, right? What are we cubing to get 125? 5. Okay, so 5 is our B, right? And then we're just going to follow this pattern. So I get A, which is 3x plus B, which is 5. The only really tricky part is the next term. A squared is going to be the quantity 3x squared. It's got to be in parentheses because I'm squaring the whole thing. What is 3x quantity squared? 9x squared. I have to square the 3 and square the x, and I get 9x squared. Okay, minus, what about AB? Well, think about that. AB is 3x times 5. What's that? 15x. Plus B squared. B is 5. 5 squared is 25. And remember, that trinomial in these patterns is always going to be prime. So we're done. This is our answer. Okay? Good, good? All right. The next most frequently missed problem was this one. And I get it. I mean, this is a little bit tricky. So what's the pattern we're going to use here? Well, yeah, but we don't really have a pattern for the fourth, do we? So what's the one that would work? Squares. Yeah, I could do A squared minus B squared. And that's an easy one. What's A squared minus B squared? No.
A plus B times A minus B.
A minus B, A times A plus B. Good. The factoring pattern. Okay, so then, now the tricky part here is we've got to figure out how can I make that first term equal something squared, and that's going to be my A, right? And the second term has to be something squared. Okay? So take a second, think about that for just a moment. I gotta see what this. So what would I square to get S to the fourth?
S squared.
S squared, there you go. Okay, good. So A is S squared. Everybody see that? Okay, well, in fact, let's write that down. So A equals S squared. What would I square to get 16? 4. Yeah, good. So B is 4. And we're just going to use this pattern, right? So then what's that give us? Well, A, you said, was S squared minus B is 4. And I get S squared plus 4. Make sense? Okay. Am I done?
No.
I'm not.
You can go further with the first one.
I can. This one is prime, but that one is not. That's a difference of squares again, isn't it? Right? So this guy, prime, But I can use this same pattern right there, can't I? S squared minus what squared? 4 is what squared? 2 squared. So what does that factor into then?
S plus 2S times.
Let me get rid of that. And then we said this guy's prime. So that one's done. So I end up with those 3 factors then, and I can't go any further. Okay, make sense? Give me thumbs on that. How we doing? Good? All right. Okay, what about one like this? Now we're moving to a different type of problem here. Notice this one doesn't say factor, it says solve. Those are different, right? I want to get number answers for this, then the numbers, values of y that would make this true. So what do I always do if I'm solving an equation? What do I do first? Set it equal to 0. Good. So we're going to subtract that 144y to the other side, and I get y cubed minus 144y equals what? 0. Good. Okay. Now my strategy is always the same. Once I get a polynomial equation into standard form, I want to try to factor the left side completely so I can set the factors equal to 0 to find the solutions, right? Okay, so I have to factor the green expression. What do I always do first when I'm factoring? GCF. Can I factor out a GCF? Yeah. What is it? Y. Yeah, take a y out. Good. So if I undistribute a y, what's left behind?
Y squared minus 144.
And 144 is really just equal to what squared?
12.
Yeah, 144 is 12 squared, so I get y squared minus 12 squared. How does that factor then? Right, that's my difference of squares. Okay, give me 1 to 5 on the purple stuff. Now, everybody give me a little feedback here. I want to know where we are. Okay. Okay, all right, so what about the orange factor? Do I get rid of it?
No.
Got to keep it. Right, it's there. I still have that y out front, and this whole thing is equal to 0. Show me with your fingers, how many factors are there on the left side? 3, yeah. Y minus 12, y plus 12. So the product of those 3 factors can only be 0 when I'm multiplying by 0. So either the first, second, or third has to be 0. Well, what's the value of y that makes the first factor 0? 0. Yeah, anytime I have a monomial, there's only one term in the polynomial, the solution is always, as long as it's a variable. If it's just a constant, it doesn't give me a solution. But if it's a variable, I always get 0 for that solution. Or, what's the value of y that would make the second factor 0? 12. Or, how about the third one? And we're done. Okay? So this is a quick one. We're trying to factor v cubed minus 8. What's the pattern we would use?
A cubed minus.
It's got to be a difference of cubes. A cubed minus b cubed. And everybody, what is that one? A minus b plus b squared. Good. And we can do this one really quick here. What's my a? V. And what's my b? 2, because 2 cubed is 8, right? So what's that going to give me then? A minus b is going to be v minus 2, right? A squared is v squared, plus v times 2 is 2v, plus 2 squared is 4, right? Make sense? Okay. All right. Okay, this one. Now, could I factor out a GCF here? I can't. Yes, you may. You bet. So this is going to be one where we have to do that split, you know, we have to find magic numbers and split and group, right? Whenever we have a trinomial where I can't factor out a GCF, I'm stuck with the coefficient of x squared not being 1, then I have to use split and group. Now, sometimes people are using split and group all the time though. Don't. If you don't need to, don't use it. Like, what about a basic trinomial like that one? Do I have to split and group that one? No, I don't, right? Basic trinomials are easy, easiest possible things to factor. I just make a template, and if I find magic numbers, I just put the magic numbers directly into my factors. What would have to go here and here? X's, right? And what do my magic numbers have to multiply to? Negative 48, right. So my magic numbers multiply to negative 48, and they add to negative 2. So what are the signs going to be if they multiply to a negative and add to a negative? Negative and positive. And what are those magic numbers? I'm done. I don't have to split and group. I just make the template and put the magic numbers in, right? Those are easy. Okay, this is a little bit tougher when we have one like that. Okay, so now I do have to find magic numbers and split the middle term and then factor by grouping. What do my magic numbers have to multiply to?
21.
Yes, right. They multiply to the outer product, right? Product of the outer coefficients. So they have to multiply to 21, and they have to add to what? Yeah, they're going to add to the middle coefficient. So what does that tell me about the signs? Both negative, and what are they? There you go, negative 7 and negative 3. So then what does that middle term split into? Negative 10x is going to split into negative 7x plus negative 3x. Good. And everything else just stays the same. Okay, now I've got 4 terms, so how do I factor? Grouping. Factor by grouping. Good. So group 1, what do I do? Take out an x. And then that leaves behind what binomial? So what do we know, what do we do first in group 2? And what would have to be out front for that to work? Everybody agree? Negative 1? Okay, so then we're about done. I factor out the binomial, and what's left behind if I undistribute that? X plus negative 1, which is just x minus 1, right? Okay, give me 1 to 5. Okay, good. So that's different. We do need split and group there, okay? What about one like this? People did pretty well on this. They set it up, but they just didn't quite finish the problem correctly. So let's read through this. One positive number, and that's important. One positive number exceeds another positive number by 7. So I don't know the numbers. What would I call the first number? X. What would I call the second number?
X plus 7.
X plus 7. Okay, look what it tells me. Their product is 78. Okay, so product means what? Multiply. So x times x plus 7 equals 78, right? So I get an equation to solve. What do I have to do to solve that equation?
Set it equal to 0.
I have to set it equal to 0. What else do I have to do? Distribute. Yeah. So I'm going to distribute the x and get x squared plus 7x equals 78. I'll subtract the 78 over to the left side and get x squared plus 7x minus 78 equals 0, right? Let's get all those Chromebooks closed up. So now I've got it in standard form. What do I have to do to the left side? Got to factor it, don't I? And it's a basic trinomial, so it's going to factor easily or it's not going to factor at all. Okay, those have to be x's. If my magic numbers multiply to negative 78 and add to 7, what are the signs? Positive and negative, right? And then if we wanted to make a table, we could. We may not need to, but if we wanted to, m and n, right? And let's see, one's positive and one's negative, so we'll make the biggest one positive and the smallest one negative. And because they multiply to a negative, I would just pick numbers that add to 7, right? Like I could do 9 and negative 2, but those don't multiply to the right thing. They have to multiply to negative 78. Those only multiply to negative 18, so I got to skip down, right? How about 11? And 11 plus what is 7? Negative 4. So that gives me negative 44. Still not big enough. What do you think?
Maybe like 13 and
Let's try that. 13 and negative 6. And that gives me negative 78. So we got it, right? Okay. And you may not have even needed a table there. That's fine. So we get x plus 13 times x minus 6. So what are my solutions then?
It's going to be 13 and whatever 13 minus 7 is.
Okay, now hold on. Think about this. I've got a product of two factors. So I've got to use the zero product property to find solutions first. So what value of x would make that factor 0? Aha, okay, so don't make the mistake of thinking the magic numbers are the solutions. They're not. Negative 13 is a solution. Let's see why. If I plug that back in, I get 0 plus negative, or 0 times negative 19. Well, what's 0 times negative 19? 0 times anything is. So that worked. That's a solution. Okay, how about this one? What's the 0 of that factor? What minus 6 is 0? Okay, if I try that one, I'd get 6 plus 13 is 19 times 0 is 0. So those are my two solutions to the equation, right? Okay, but remember, we're not just solving an algebra equation. This is an application problem. It's a word problem. Our numbers have to be positive. So what's the only solution I get to keep? 6. Yeah, this is not positive. So I've got to cancel that one out. So my solution, my algebra solution, the only one I get to keep is x equals 6. Okay, but I need to find both numbers, right? It says find the numbers. Well, if x is equal to 6, I would just have to feed that x value back up into both of my expressions for my numbers to see what I get. Well, what does that give me if I plug in 6? 6 and 13. Those are my answers. Okay, make sense? Okay, so a lot of people were really close on that. Just at the end, they didn't quite finish the process. Okay, we're getting there. What about this one? How could I make this one easier? Is there a substitution that would make this a little bit simpler?
Y squared is y.
I'm going to let x squared equal y, right? Now, some people made a substitution, but they didn't change the variable. They said x equals x squared. We got to change. It's got to be a different variable. So we're going to change it to y. We're going to replace all the x squareds with y's. Okay, so what does that do? Well, x to the fourth is x squared to what power? Yeah, that's x squared squared minus 4 times x squared minus 5. So if we make a transition here, we could transition from x squareds to y's, and that's just going to become y squared minus 4y minus 5. That's a basic trinomial, right? I have to find magic numbers that multiply to negative 5 and add to negative 4. What are they? That'd be a negative and a positive, right, if they multiply it to negative 5. Negative 5, positive 1. I agree, right? And then the last step, well, we got to go back to the original variable, which was an x. So this just becomes x squared minus 5 times x squared plus 1. Good? Okay. How about this? Okay, this is really a simple one. What do I do first here? Move the 21 to the other side. And what's that do then? That gives us the equation w squared minus 4w minus 21 equals 0. Well, that's a basic trinomial, right? That's easy to factor. I set up my template. Those have to be w's. What magic numbers multiply to negative 21 and add to negative 4? You have to have a negative and a positive, right? Say it again. They have to multiply to negative 21 and add to negative 4. Negative 7 and positive 3. So what are my solutions then? W equals 7 or W equals negative 3. Good. I know. We're going to make it though. I think this might be our last one. So this looks hard. It looks like I'm going to have to split and group, but what can I do to make this easy? GCF, you betcha. We're going to factor out an 8, and what does that leave behind? That's a basic trinomial, right? Again, these basic trinomials are easy. I've got my 8 out front. What are my magic numbers? They have to multiply to positive 8 and add to negative 6. So what are the signs? There you go. Negative 4, negative 2. We're done, right? And let's see. We did that one. And okay, last one. Hang on real quick. We'll be done with this. You can have a full work day tomorrow. This is done, right? It's already factored. All I have to do is the zero product property. When is the first factor equal to 0?
Negative 2?
Yeah. X equals negative 2. Okay, what about the other one? Well, this is a little tougher, so we could just set it equal to 0. 2x minus 5 equals 0. What are the 2 steps to solve for x?
Add 5 divided by 2.
So I get 5 halves, and those are our 2 solutions. Good? Okay. Test Thursday.
One of those TA papers.
I